Welcome. We're going to give a couple minutes for some late arrivals to show up, and then we will get started. Thanks. Hello and welcome to our webinar today, Make the Savings Real with a Standardized Network Lighting Controls Configuration Report. My name is Jason Jeanette. I'm a technical manager with the DLC. A couple housekeeping notes as we begin. These slides and the recording of this webinar will be posted on the DLC website, and everybody is automatically muted. If you have any questions during the presentation or afterwards, please submit them in the questions pane, and we will go through them. The DLC is an independent nonprofit organization that provides decision makers with data and resources on quality lighting controls and integrated building solutions. Our whole thing is energy savings. And we're here to talk about some work that is not actually ours, talking about a new NEMA ANSI standard for network lighting control configuration reports. This project was initiated by a NEMA committee back in September of 2021, and the standard was approved in December of 24 and finally published this past March. There was a dedicated working group that did all of the work on this. I'd like to call out Ruth Taylor and Michael Davidson, who are the co-chairs of that working group, as well as Harold Jepson, Yao Zheng Wen, Chris Wolgamott, Brian Woodbury, Bob Hamlin, and Robert Sapolsky. All did some great work, and I was on that committee as well. So stepping back for a moment, why are NLC settings important? Like, why does anybody care about this? At a very high level, there are regulatory requirements for efficiency programs. Utilities very often require approval from regulators to invest in their expansion, to build new power plants, new grid lines, all of that. Energy efficiency overall is encouraged because it's far less expensive to pay for everybody's lights than it is to build a new power plant. And as part of that, regulators assign goals for specific amounts of savings, both electric and gas savings, emissions reductions, market transformations, energy equity, a whole bunch of different things. For the most part, these energy efficiency programs are paid for by funding from ratepayers. Investor-owned utilities are regulated, usually at the state level, and their policies vary state by state. Most states have some kind of, they call it demand-side management as part of rate setting, and the goal is often set as a percentage of electric sales. And if the utility can verify the savings that they are claiming, then they're allowed to recover their program costs. Each state does this slightly differently. About 26 states have what they call energy efficiency resource standards. Many other programs have voluntary programs, or utilities have voluntary programs. It's all different in Canada, just like so many things. And there are various different levels of funding and policy and how strict they are and all of that. So this varies a lot. One of the common patterns, though, is that these programs are all governed by technical resource manuals. And last spring, we published a review of those TRMs and how they relate to network lighting controls and luminaire level lighting controls. So please check that out if you are not familiar with it. In a high-level overview, these technical resource manuals contain control savings factors, which is the percentage of energy savings that energy efficiency programs are able to claim based on a specific lighting control strategy being implemented. And those range from an average of 25% for just plain occupancy sensing, standalone, up to an average of 58% for luminaire level lighting controls. And those TRMs, like I said, govern those programs. Now, programs are delivered in a few different models. Sure, everybody is familiar with the idea of prescriptive and midstream programs, as well as custom. So some are kind of high volume, some are more low volume, but specific products, and have a lot of paperwork. Particularly custom projects involve a high level of administrative paperwork. Now, utilities and implementers take these program models and the rules from the TRMs and translate them into specific rebate amounts for specific products. Run a program, they give you $60 for a remote mounted dual sensor for that year. And at the end of the year, they have to wrap up everything and go through a cost effectiveness evaluation. And the basic question there is, if you pay out $5 million in incentives for a year, and you claim 45 gigawatt hours of total energy savings, is the value of that total energy savings more or less than the amount of the incentives that were paid out? This is really important for the utilities because the outcome of that question, the answer to that question, will inform how much they can claim for that specific measure in subsequent years. So if they miss for a year, that can cause knock-on effects for another, sometimes 3 to 5 years after that. Now, with lighting changes, this was relatively easy. For instance, if you take a 400 watt metal halide and switch it to a 150 watt LED, you know that you're saving 200 watts or so, 250 to 200 watts. We have a big giant list of energy efficient LEDs that helps utilities verify that. They can point to our list. I'm sure many of you are familiar with it and know what the wattage draw connected load is for a specific luminaire. When you get into controls though, we're not talking about connected load, we're talking about energy usage, and that becomes a little bit more complicated because the energy usage of lighting controls depends on the programming, the users, the weather, the S&P 500 last week, and who is the top of the Billboard Top 100. So there's so many variables that go into it that it's very difficult to collect reliable data and evidence to back up these savings claims. So you might say, oh, people are doing this today. How are they doing this? There are two major ways that utilities are collecting programming information about network lighting control systems today. One of them is contractor attestations. the contractor to sign a form that says, I pinky swear that I set this up correctly. Another way is app screenshots. So the contractor will need to submit screenshots of the setting pages of various rooms in a project, sometimes every room in a project, sometimes a selection. And you can imagine when you get into a larger project, that becomes pretty unwieldy pretty quickly. It's a lot of files to manage, a whole bunch of stuff. So that's the background for where the idea of this NEMA ANSI C137.9 standard came from. The goal here is to provide a high-level overview of the configuration settings for a specific installation of a lighting control system. The standard does not provide energy use data. There's a different standard for that. This one is only about the settings. This standard was written with and for the energy efficiency programs, just making sure that we're meeting their needs and goals. The idea is that reports are generated by the network lighting control system itself or the programming device while it's connected to it. Those reports are organized by space type, and those reports can be generated on demand, either by the system itself, like if there's a gateway or a server involved, or for quote unquote headless systems, if there's a programming device connected. While that device is connected, it should be able to generate that report. Here is an example of what the report looks like. I'm going to go through it in detail to kind of explain all the different pieces. Excuse me one second. First, we'll start with the header. So there's some information about the company that made the prescriptive, what the system name is, as well as the name of the project, and a timestamp for when that report was generated. Then groups of columns, looking at spaces. We have the ASHRAE 90.1 space type. So there's a list from the ASHRAE 90.1 energy code. It's somewhat condensed from that list, but references that, as well as the number of areas in this space type in the specific installation. Then we get into quantity of luminaires controlled. So there's the number of luminaires controlled as well as the number of LLC luminaires in that specific project. Then the configuration columns for those luminaires focused on different daylight or lighting control strategies, starting with daylight harvesting, then scheduling. These are both yes or no answers. Then occupancy sensing, is it enabled? Yes, if it is it manual on, manual or auto on? As well as what is the timeout for those sensors? And then what is the high and trim level setting for the lights in that room? Let's see, sorry, I have one question. I've not actually shared any other slides or any other files besides this. I'll share a link to where you guys can get the standard later on. But for right now, we're just looking at slides. Okay. And then next, we move on to, sorry, I'm seeing, no slides. Lauren, are you seeing that? You're seeing the screen, right? Sorry, I just got into the, some people aren't seeing slides. Okay. Greg, you might have to play with your window to find your slides. Sorry, moving on. The last part is the watts controlled. So this section can be either the measured value of the watts controlled or user input. And that really depends on the capabilities of the system involved. Some systems are capable of actually measuring the wattage that flows through them. Others will calculate that wattage based on a value that's entered at some point in the process. And so the report will state which one the system is, but it's designed to accommodate both scenarios. And those columns are the total connected load. So what is the connected load for all of the luminaires in that specific row? What is the effective connected load after high-end trim has been applied? And then moving on, what is the effective connected load of luminaires that have occupancy sensing enabled, as well as daylight harvesting enabled. So going through a specific example in this report. So this building has 6 private offices. In those 6 private offices, there are 25 luminaires with LLC that have daylight harvesting enabled, scheduling enabled, occupancy sensing enabled with manual on, a sensor timeout of 10 minutes, and a high and trip level of 85%. Those 6 offices also have 6 more luminaires that do not have daylight harvesting enabled, but do have scheduling enabled, occupancy sensing and manual on, timeout of 10 minutes, and a high interim of 85%. The way the report works is that for each luminaire in the space type, each time the configuration changes, those luminaires get reported in a new row on the report. Can take a little bit to get used to it, but it'll make sense eventually. Okay, so we have this fancy report. A standard for this report has been published. Now what's the next thing? We need people to adopt it. So the next steps that we have right now are we need energy efficiency programs to start asking for these reports. Initially, it would be in addition to whatever submission they are using to verify projects today. So please update your requirements to be like, hey, you can submit screenshots for this report. And then at the same time, we need NLC manufacturers to add support to your products. I've already heard from 3 manufacturers that are working on it right now, and I know we have several more on today, and hopefully they will start. For the DLC, our next steps is we plan next year to add whether or not support for this standard is included in a system to the NLC QPL at some point next year. It'll be as an optional reported. So if a particular system supports the standard, we will say it supports it. But if another system does not, we won't say anything at all. And then in 2027 or 2028, we're going to make it a required reported item so that if a system supports this, we'll say yes. If a system does not, then we will say it does not support this. Questions? I see we have one question. How does the product obtain access to this report standard? It's a good thing you asked. Here is a link to where the standard can be purchased on the ANSI store. I'll just leave that up there for a little bit. This is a short and sweet webinar. I apologize for going too fast, but I hope if you have any questions, please put them in the question pane. For us, there is no cost for us. This is a public standard, so once you buy the standard, or manufacturers buy the standards and they implement that, update their products to generate a report that meets the standard, there's no cost for that. And then for the NLC QPL, as far as reporting whether or not this system meets that standard, that will be part of the annual update. I don't believe there'd be an extra cost for that. I think, does that answer your question, Gail? So I'm going to come in, I'm going to scroll up here. We had a question that I mentioned this standard does not provide energy use data. There's a different standard for that. Michael, unfortunately, I don't know the answer to that off the top of my head, and I apologize, I really should. But let me find that for you and I can send it to you afterwards. I know you can find it in, it's a NEMA report. It's in the C137 range. I think it might be either .7 or .11. I'll have to look. And if anybody knows, please put it in. Let's see. Oh, I see. The question about the cost of a report. So if the contractor asks for the report, I'd like to be able to tell them a range for what it might cost and can be purchased after the fact if the product doesn't already have reporting access installed. So that I don't have the question to. Exactly how individual manufacturers make the choice of implementing this report capability within their systems, I can't tell you. There's nothing in the standard that says that a manufacturer can't charge extra to generate those reports. My hope is that they won't, and that it becomes it's a capability that comes with the system, and that there is not an individual charge for report generation. As far as answer the question of whether an existing system could be updated to generate that report, that is also a distinct possibility, but it would depend on the specific implementation from a specific manufacturer. I will say there are some data points shown in the report, like the space type of where a specific product is, or a specific network node or lighting controller is located, are not typically entered in the programming process today. So it is theoretically possible that a system that is installed today, if the firmware of that system is updated later on, that then reports could be generated, but there would be some form of almost a recommissioning process or reprogramming process that adds missing information. So typically today, when systems are programmed specific, in particular, like Bluetooth NLC systems that are, I'm just going to call them headless. The system isn't required to record where each node is. For like an NLC product, we don't know that there are, 5 lights in my office. It doesn't necessarily know that. So we would have to go through and say that there are 5 lights in my office and 5 lights in somebody else's office. But as long as that work can be done, then the report can be generated afterwards, assuming everything is updated. I apologize if that's a long answer. I hope that helps. All right. Any other questions? Thank you for joining me on a very quick, less than 30-minute webinar. Have a good day.